All right, so I wanted to give you guys a little help with homework question 7. It was requested. So the hardest part for students with number 7 is that we're given a contingency table like we're used to seeing from part 2 with the actual counts or frequencies in them instead of the actual probabilities. So that's the only thing that really makes this difficult for us. Otherwise, we can really treat this very, very similar. So the first question we're asked is, what is the probability that a person is short and does not have the disease? So we're looking for probability of short and no disease. This is something normally we would just pull straight off our table, right? We would go, look, here's short, here's no disease. Those things intersect at 104. But 104 is the number of people, and we don't want a number, we want a probability, right? So all we have to do for this is take the 104 people and divide them by the 1,000 people there are overall, our total. So if you wanted to, you could even go through this whole table and convert everything here to probabilities just by dividing through by 1,000. And then you would have probabilities to be working with, which might make you feel more comfortable. So I'm just throwing that out as an option. So that's all you needed to do for the part A. So 0.104 is your answer. Part B, we're asked for tall or mild. Unfortunately, this is not something that we can grab directly off the table. This is something where we would be needing to use our probability rules, right? So you'd need to do something like probability of tall plus the probability of mild minus the probability of tall and mild. Or you could even just do this like we used to. We actually answered this question before. We just need the total number of tall. So the total number of tall is 400. We need to add the total number of mild, that's 200. But what happened when we were doing that is that we double counted these 78 people twice. So then we got to subtract off that 78. And if we were doing these as probabilities, every single one of these would have been over 1,000, right? So whatever the heck this number is, I think it's 322, is going to be divided by 1,000 or 0.322. The only time you're going to divide by something other than 1,000 is in Part C. Part C, you're told if they have a mild disease status. So now we know we're in a certain subgroup, right? We're basically doing a conditional statement. That's where you're headed for Part C. I'm not going to do it for you, but I think that hopefully that if will help you. You can either do that just intuitively or you can set up the conditional probabilities. The last piece of this that students were having a ton of trouble with is answering whether or not they're independent. If you just think logically, you think there's no way disease status is at all influenced by how tall you are, right? But this is some certain made-up disease. They haven't told us what it is. We know nothing about it, so we can't make that assumption. We have two things that we could test. We could test any of our and probabilities. There are a bunch of options here. I'm going to go ahead and use the one we did in A. We already have an answer, probability of short and none. If these things are independent, the probability of short times the probability of none should be the same as that and, right? That's the independent rule. And then we can just plug and chug into these two. 104, does that equal the probability of short, which is apparently 350 all over 1,000, times the probability of no disease, which is, looks like 300 over 1,000. It's up to you guys to check. Are these the same? The answer is that they're not going to be the same. So no, these are not going to be independent. They are dependent. Turns out there is some sort of relationship between your height and this bizarre made-up disease status. So hopefully that helps you out with question 7. That's it.